About the profile of Sir's education. Sir has finished his PhD from University of Sydney. He holds a Master of Design from Indian Institute of Science. His bachelor's is from from Birla Institute of Technology. Some of the projects of Vishal Singh Sir include a project on sharing in design, BIM, IoT and link data in construction and facilities management, interactive learning platform for building and construction education, multidisciplinary expertise in design and design teams, digital construction workflows, generative and algorithmic design in architecture and construction, agent-based modeling and simulation for design studios. So a brief introduction about his professional experience includes he was serving as assistant professor in Aalto University, Finland. He was also the co-founder and chairman of board of Visual Link OI in Finland. He was the director, Construction Innovation Hub, Helsinki Metropolia University of Applied Sciences, Finland. He also holds a postdoctorate research fellow from Deakin University, Australia. He was also the research assistant in University of Newcastle, Australia. So it's been a privilege to have Dr. Vishal Singh with us. Thank you, sir.
Right, thank you. Good morning. I'm sorry for the delay. I was coming from the other side of the city, so I have no idea how long it will take. And many thanks for the generous introduction. I think my entire CV was almost read, so all right, I'll take that. So this is going to be a talk which is generic in nature. So just to get an idea, what is the background of people here? What is the average background? What are the disciplines? Which all disciplines do you come from? How many are people are from, say, computing background? How many from core engineering backgrounds, mechanical, civil? All right, quite a mix. Okay, so good. So because my talk is very generic, so I'll talk about and there are lots of videos. I hope all the videos play because they're all YouTube links. So I'll talk about Industry 4.0, 5.0. And at some point, I will also ask you to engage because it will not be a one-directional talk. Because otherwise, you could readily be watching your mobile and sitting here. So instead, make it an activity where you also engage and do some activities together. As introduced, the topic, given topic in some sense is Industry 4.0, 5.0, and what opportunities it offers in design and for manufacturing in construction. So this is a bit about, I'll start with a bit about my group. So Prajwal is doing a PhD in my lab. He's also a student from here, so it's good to have him here. My group is called Impact for Impact Lab. So we largely focus on innovation and management, in property, architecture, and construction technology. So we focus on real estate, but our background comes from cognition, computing, and design. So cognition is basically how you think, how you recognize things. So we do a bit of work which also draws from psychology. All of that goes into developing computational tools which help you make better decisions. So if you are familiar with decision support systems, that's one of the areas where we work in. So you understand how people make decisions, and in order to support those decisions, you develop computational tools which help you make better decisions. That's what we focus on as one of our core areas. And of course, to do that, we leverage computing and we apply design principles and design methods. I'm not going to do much of detail, but largely, in my, as introduced also earlier, we look at three different broad topics. One is the built environment and living spaces. So how's the space around you? How do you design them better? How do you improve them better? And where is the future of where you live? Where is it going? Right? The second topic sort of looks at how do you make design decisions? How do you improve designs, and of course design impacts what you eventually get as an outcome. So we spend a little bit of time on understanding design, and that design also for manufacturing In the built environment segment also we are looking at how do we build differently. Right now, if you think of construction, and you think of a lot of pollution, you think of dirty sites, and when you compare it to manufacturing, it is very different. Right? I'm going to pose a question on that as well. And the third, of course, is whether it's design, whether it's built environment, we want to bring innovation in the market. So how do you? So what are the factors that determine whether your innovation is going to be successful or not? You can create solutions, but does it see the end of the day in the market? Right? That's where innovation ecosystem, innovation management comes in. So we look at it as supply chain as such. Okay, so this is an image that's taken from a report from World Economic Forum and Boston Consulting Group. So they looked at where construction is heading. So this slide sort of captures many different areas where they're saying these are the key technologies which are going to impact construction in the future. So there are, as you see, one of the core areas is prefabrication, modular construction. We have building materials, a lot of work going there. 3D printing, additive manufacturing, we have already probably heard of the post office that's built in Bangalore using 3D printing. I have video of that, you'll see that. There's a lot of things in the digital space, so you're looking at big data, predictive analytics, augmented reality, wireless sensing, monitoring. This is where Industry 4.0 sort of combines all of these technologies, right? So that's what we're going to look at. And of course, building information modeling. How many of you are familiar with what is building information modeling? Nobody? BIM? Yes, Revit is one of the BIM tools. Good, so at least some familiarity is there. I'm not going to talk about it per se in detail, but of course, some familiarity is useful. So when the time comes, I'll ask you a question: what is BIM and how it is different from other CAD applications? So you can prepare your answers in the meanwhile. Okay. All right. So largely, you see this lots happening, and hopefully, in the next 15-20 years, we'll see construction as a very different sector compared to where it is today, and also maybe more closer to manufacturing. So as of now, construction seems to be slightly different than manufacturing, right? I'm going to ask what is the difference. That's again part of the exercise we'll do. But again, so I'm just giving heads up so that you are prepared for that question. Now, amongst these technologies, this same report sort of also looked at which technologies are likely to have the greatest impact in the near term, right? So you have many promising technologies. So we are talking about 3D printing, we are talking about drones, analytics, we are talking about wireless monitoring. So if you look at the scale, what it is saying is what is the likelihood in terms of the impact of the technology, which technology is likely to make the greatest impact, that's higher on the scale, and which will have the highest impact. So one is which is likely to have impact, very likely, so likelihood of something making an impact and the scale of impact. And then we see integrated BIM as the far end, saying that, okay, because eventually, if you are managing a project, you have to be able to manage the information, right? Information has to flow, information has to be documented, and that has to connect to your fabrication or manufacturing capability, right? So largely, if you are able to manage the information well, you will be able to manage the project well. This is where integrated BIM comes, where right from the beginning of the project, if you are designing on a BIM platform, if you are manufacturing using a BIM platform, that's the integrated environment, you are likely to see the impact, the most impact coming out of there, right? All the other things will of course enable it. So BIM in some sense will be there in almost all projects. You may or may not use drone in some projects, you may not use some of the other technologies, you may not necessarily be doing modular construction, but whether you are doing modular construction or not, you are going to use BIM, right? In the sense of you are going to use information, you are going to use tools that allow you to connect the information from one stage of the construction to the next stage of the construction. So feel free to stop me, I tend to move fast, so interrupt and then ask questions. So this is again, if we look at one of the other things I'm trying to do at the moment, this is again a work in progress. For now I have marked it as lab, but we are trying to build a center of excellence on smart manufacturing and construction at ISC. And these are some of the areas that we have to focus on. One is productization of buildings and built environment, essentially saying that right now, if you think of construction, you think of projects, right? Each construction is a project. Whereas if you think of manufacturing, you think of products, right? You think of a car, you think of supply chains, you think of the assembly lines, where the construction is typically thought as one project gets there, where it starts and so on. Right? We do not think in terms of products necessarily in construction. So the idea here is that how we move from this idea of project-based way of working in construction to product-based ways of working in construction. Right? So you build products and then you move them around, and we'll look at what that means. On the same lines, if you think of product service systems, how many of you understand what a product service system is? Okay, you can make a guess as well. So if you don't understand, you try to make a guess. I can tell you, but that's not a good idea. So anyone volunteer would say what is a product service system? With an example. There's no right or wrong answer. We are just sort of product service system. Nobody wants to even try a guess. Okay, Raju.
Okay, so typical example would be in terms of
Loud.
Okay. So a simple example would be in terms of, say, you're designing a product, right? So you're designing your product for some particular purpose. So that it's not you designing a product at a particular instant, but how is it that is going to get impacted throughout the life cycle of the product, right? From you designing something to you essentially taking it to the customer part of it. So that can be looked at product services.
Okay, now not there, but close but not there. So product service system is essentially, yeah, please. Louder.
Product that is satisfying the customer.
Well, I mean, I can have a product which also satisfies the customer. If this is a product, satisfies the customer, it doesn't become a product service system.
The supply chain, what you do to the demand, what is it?
Yeah. Okay, so let me, before that, you can ask a question. What is the difference between a product and a service? You've heard of service? You've heard of products? What is the difference?
The maintenance part is service actually.
Maintenance part,
Give
yeah.
the support for maintenance.
Yeah. But if I just do a service, hospitality is service, right? So what is the maintenance part there?
So that
Banking services, from financial services, you also have financial products. What is the difference between a product and a service? You're right, there is an element of maintenance in the service part, but that's not the only part, right? I can just be offering service. So for example, if you do a call center job, you are doing a service, right? You do not necessarily have a product.
But that is not the service we're talking about.
Service more.
Well, we are talking about the definition, so we'll keep it broad as of now.
Like
Then we'll
call
go-
center,
yeah.
call center is running, it requires certain equipments,
Right.
like maybe the audio, maybe
Right.
the voice, whatever.
Right.
So the service is required for those support system we can call it.
Right. Right. Yeah.
And all these are the like software products and services we get from that are like designing service they provide us. All these are like under service.
Right. Okay. So let me go. I think there was another comment somewhere there. Yes.
So service can essentially be more towards providing a support through the life cycle of the product.
It doesn't have to be only support. That's my question. I mean, I can directly offer a service, right? So a chartered accountant provides a service. So it's not just about the support, right?
No, your service is more towards the support, right?
Okay. So let me sort of again, in the interest of time, I'll sort of touch upon that. So a product is where you sell the product and whoever owns the ownership of the thing is transferred to the other guy, whoever is the customer, and the customer then extracts the function from the product. So even if I buy a financial product, I'm buying an insurance. At that point, insurance is not a service because I have bought the product. Which of those insurance? So you have 4 types of insurances that you are selling, right? And I'm buying which one, and then I control how I'm using that insurance. So the control of getting the function out of the thing is passed on to the consumer. In that case, it becomes a product. When the control is left with the service provider and the consumer gets the function, then someone else is giving you the service, they actually maintain the thing, right? So if you look at, I'll give an example again, a little more tangible example. So you all have heard of Xerox as the company, right? The copy maker, print maker, photocopier. So earlier, Xerox used to sell the product, right? They would sell a photocopier to you. Then they moved into a product service system where they said, fine, you don't have to buy the product. We lease the product to you, you get the service out of it. And we'll maintain the product for you, we'll sort of do everything. Like in the phones as well, right? You can buy a phone directly as a product. Or you buy a phone as a product service system. You say, fine, Reliance is providing the phone, and and so they're passing on the product to you, maybe for free or maybe in some cost. But they are actually saying that, okay, if you are buying a Reliance phone or phone to us, you will use our service. So you're combining the service, which is the service provider's thing, with the product, right? So product service system has become again very interesting as a segment because most companies want to get there. Because if you're only selling the product, you are getting one-time return. But when you move into product service system, you are locking your customer into longer term relationship, right? So in fact, now if you buy cars, you are not just buying a car. They say, fine, we'll monitor your engine, how it is performing, how is your car performing, right? Then they will say, probably now we are monitoring your car needs some maintenance. You bring it to us, we'll maintain it and then service it, right? So the model where business is moving is more into product service systems, right? Where you do not only sell one time because the value you get is not, returns you get as a company is lesser than you get for a product service system. Do I make sense? Yeah. At least with that, so that's again a very important way to look at it, because if you now think of service apartments, you are not selling just the product, you're not just selling a unit, you're saying, okay, we'll maintain the service, we'll provide you all of these. And in fact, a lot of gated communities in some sense could become sort of product service system in some ways if you think of it, right? So yeah, so that's another area of interest, industrialized construction, where we are saying, okay, how do we leverage manufacturing methods into construction and not do construction the traditional way. That's the other area of interest. Related to that is the prefabrication, volumetric construction, modular construction. How many of you are from mechanical background? Okay, nobody is from mechanical, but you have heard of design for X, DFMA in civil engineering? Anyone civil engineers here? Okay, so you have heard of design for assembly? No? Okay. So basically the idea here is that, well, the idea comes from engineering design in general, but more so in mechanical, because you typically make parts, right? And you'll assemble parts. A typical embodiment in mechanical engineering will be that you'll have parts and subsystems and you are assembling the subsystems, right? Now, when you are actually coming to this situation where you are assembling the subsystems, you can design it in such a way that the assembly is very easy to do, or you can design it in such a way that the assembly is difficult to do, right? So DFMA largely looks at, during your design phase itself, have you considered the manufacturing requirements? Have you considered the assembly requirements, right? So if I'm going to design for, say, 3D printing, am I going to design the same way as I'm going to design for a regular thing? Or do I consider what 3D printing requires in my design considerations? Similarly, if I'm going to design for something to be assembled much later, so let me give another example for that. So you get many different variants of, let's take an example of a, say, printer, regular printer, right? Your desktop printer from HP or any other company. Where does it get assembled? It has many parts. Would you agree? A printer has many parts, right? Where does it get assembled? Where it was produced, or does it get assembled much later? Where and why? Does it matter? Should we think about it? So now imagine, let's assume that there is a factory in China somewhere, right? Which is making the parts of the printer, all the parts. One possibility is that they assemble all of it and then ship all assembled printers from all the way from China to India, right? What will be the cost of transportation? The challenge could also be, now let's assume that each of those are pre-assembled and sent. So now let's say if you have a retail shop somewhere in Bangalore, or even a dealership, right? For each, let's say there are 3 types of printers, A, B and C. So you don't know what is the demand variation that will happen. You might have some idea, right? So which means that let's say if I am selling 90 printers every day, and more or less assume that, okay, the average each of them sell 30 or so on. I have to keep at least 30 of each of those, right? And some days the variation will be that there will be 45 required for A and fewer required for the other one. Which means that I have to have much larger inventory of each of them, which occupies much larger space. But if the assembly is happening somewhere closer, I keep the parts. And depending on the demand, I'll assemble those which are specifically required for that particular day or that particular period that you're looking at, right? Am I making sense? Alright, you guys are sleepy already in the morning, so you need to bring a little more energy. Okay, So this is where a lot of other considerations come in, that you do not when you design, you have to also consider these ideas where it is being and of course part of it is to even plan the logistics and supply chain to say where should assembly happen in the process to be optimal in some sense, right? Then of course all of these is enabled by digital technologies. So we are looking in this case BIM, as some of you are familiar. Digital twin, at least that would be a word familiar to everyone in some form or the other, I'm assuming, right? And of course other kinds of digital technologies that's also happening in all domains and including in construction. And with the Industry 4.0 approaches, we are also looking at Construction 4.0, 3D printing, smart sustainable materials. Not my group does not work at all in materials, but of course we have colleagues who work in materials. Construction robotics, yet as a group department which is in design and manufacturing, we are also interested in products and equipment that allow you to make them and do construction. Right? So it's not just what you build, but you have tools and machines that help you build, right? Equipment. So how should the design of the tools and equipment change if you want to change the way you construct, right? So that's again an area of interest. And of course, all of this in today's world is getting mediated by AI. So how do you do it responsibly, right? So responsible AI in the context of built environment. I'll not go into details of each of these. These are early stage research topics in various contexts. Now, okay, I've already put some slides there, but what is Industry 4.0? We have a common ground there. Everyone has some understanding of Industry 4.0. Alright, so a quick recap, what is Industry 4.0? Right, and good. So, yes, all those are enabling technologies, but why are we doing it?
So world is growing and like our need are growing, so everything is like improving day by day.
But how and why? I mean, why do we need it in the first place? Everything is improving, that is true. All you said is technologies, that's also true. Those are enabling technologies, but why are we doing it in the first place?
Increase production.
Okay, increase production. We could increase the production capacity without doing these things. What else? Why? So what else is the reason? What is it? What is Industry 4.0 enabling that wasn't possible without Industry 4.0? You had breakfast? All of you? Okay. You need to reflect that in your discussion. Automation, right. So automation we had before Industry 4.0, right? We have been doing automation since Industrial Revolution, right? So what is Industry 4.0 enabling which wasn't there? Yeah, I think I heard something about communication, someone was saying.
Connected systems.
Yeah?
Industry 4.0 reflects in how we can make a connected system, where like information gets connected across different entities.
Right. So Industry 4.0 is enabling connected systems, right? What is connection enabling? And why are you doing connections?
So if you're looking at it if you're gonna take it one step behind, right? So there were systems wherein we can essentially look at it in terms of increased manufacturing, all of these specific aspects of it. But while essentially getting a system connected and like sharing that like this is what is going on, right? So we are able to make sure that like some aspects of what the end result that the SBC right, that can essentially be taken forward. In a sense, so if you're giving a specific example, so if you're going to take a manufacturing scenario, so there are sensors which are essentially used to say like a machine is potentially going to go down based on the trend of how the output is, right? So that essentially gives you an idea of when you can essentially do a maintenance sort of scenario.
Right. Yeah, so largely what you're trying to do with Industry 4.0 is you're trying to create connected systems, right? Eventually everything works as part of a larger system. And if you're able to monitor, track, have information flow, then you can do all kinds of analysis to say whether things are going as desired, right? So the communication enables your automated systems to connect to other automated systems, connect to people who are supposed to be monitoring them, people who can communicate to other people. I mean, there, of course, it could do without Industry 4.0, but the part, what is largely it is that we are leveraging the ICT capabilities now and the sensing capabilities now to ensure that at any point in time there's enough adequate communication happening so that all the relevant stakeholders, whether it's the machine or stakeholders as in people, have the information to know what's going on. And if there's a need to course correct, you do course correction as soon as possible. Right? Similarly, of course, that if you are leveraging this ability to gather information, basically data that you are collecting, then you can do all kinds of analysis on that, apply your machine learning and predictive maintenance and predictive scenario modeling to say what is going to happen next. Right? So you have that connectivity is the key and the core of Industry 4.0. Right? Without that, we will be typically in siloed systems, and you have gaps and inefficiencies which otherwise will only be able to track much later. Saying this happened, and you are trying to say why it happened. If you have connection, then you at runtime you would know what is going on, so that you can take course corrections, right? So yeah, so that's what it is. So essentially, right up front, it says connected system of systems. So we are looking at Industry 4.0 as a system of systems, where it's human systems, technical systems, information systems, all of them are connected to each other, right? And that's where we talk about things like Internet of Things, networks, cyber-physical systems. So largely, we have moved from the idea of standalone things to things which are part of the network. And in order to do that, we need to leverage digital technologies, we are leveraging analytics, advances in AI, ML, and of course, advances in manufacturing capabilities. So that's a picture taken again from just a project domain. It's a simple Google search kind of an image. And you see that the keywords around it are related to all kinds of technologies, as you said, enabling technologies, but the why is equally important. It's not just about the technology, but technology, of course, is there for a reason, right? Why do you want to get there? So it's always important to ask the why question, because without the why, we're just chasing technology, right? If something we can do without the need for technology, why would we do that, right? So that's the primary question that I have. In the title, the other keyword, of course, is sustainability. So sustainability, broadly, if you look at it, is the three core pillars. It's not just about environmental sustainability, but also the economic sustainability and the social sustainability, right? If it is only environmentally sustainable but not economically or socially sustainable, your solution is going to fail, right? So all three must be met for it to be a sustainable approach to what you want to do. Now, I've just taken another sort of word cloud, again taken from internet, as you see, and there are many such terms associated with it, which is related to say long-term waste reduction, recycling and all that. So those things are familiar to you. So with that, I want to come to sort of, I'm just giving the background theoretical context. I have lots of videos, so that will become more interesting suddenly. I hope that you will start to enjoy it more. Keep the kind of theoretical part shorter. So here, if you look at from sustainable manufacturing perspective, so if you combine what we talked about in the manufacturing context, what we combine, we talked about in sustainability, what you're essentially looking for is, of course, we talked about three pillars of sustainability. So my question is, what would that mean in the context of manufacturing, right? You want to have your manufacturing systems which are socially sustainable, environmentally sustainable, and economically sustainable, right? Of course, part of that from an environmental perspective would be to reduce energy and resource consumption. So if you can reduce how much energy you consume and resources that you consume to deliver what you need to produce, and that's an important element. Now, part of that, even what we discussed in terms of, let's say, the distribution of, let's say, in the context of printer, we said, where are you assembling? That's also a question of sustainability, right? If you're assembling all of it beforehand, you're producing more, you're delivering, your logistics needs to transport more things and so on, right? So if you are smarter in there, you are reducing the delivery time. You're familiar with concepts like just in time. Has anyone heard just in time? Okay, you have absolutely no background in manufacturing, I assume, right? Or any courses on manufacturing? Okay, that's fine. So just in time, again, I'll leave it at that, is a concept which comes from Toyota. So Toyota started this concept of, if you have heard of lean manufacturing or lean as a concept, so just in time is one of those lean concepts, comes from, originated from Toyota. The idea from Toyota was, or just in time, is that you do not maintain a large inventory. You understand what an inventory is?
Zero stock.
Yeah, so you, yes, so you, as minimal a stock required, zero stock to the extent possible, so that you only bring what you need. For example, let's say if you stock a lot of jobs here for somebody to use, right? So a lot of resources getting engaged may not be consumed in the same way, right? So one of the ways could be that every morning somebody brings just enough jobs so that it's consumed every day, right? So you don't have to maintain an inventory here. Again, not a very good example, but good enough to at least understand the idea of just in time, right? It's a very important concept again. If you are going to work in practice and managing inventory, that becomes a very critical aspect, right? Because inventory is not just about stocking things. It also requires resources. You need a place to store things. You need a lot of cost gets incurred on top of what you're doing there.
TVS also achieved that, sir.
Right, that's right. So just in time is now about 30-year-old, 40-year-old concept. So it's become quite popular in industry. So again, on the same lines, these are some of the sustainable manufacturing goals. I'll skip that, and details are not important. Now I come to look at state of manufacturing in construction. Because we have talked about manufacturing, we have talked about construction. So now here your activity starts. I'll take a 5 to 10-minute break. You form groups in your neighborhood and you discuss and explain to us as eventually. So each group takes, so you form a group of 4 to 5 people next to each other, right? And these are your questions. The question here is this. You don't have to be an expert in anything, right? It's a lay, simple reasoning that you can do. Everyone is familiar with construction as such, right? You have seen enough construction happening around, right? Okay? And you're familiar with automobile industry, or at least you've seen some videos of assembly lines and so on. Any industry? You've never seen a video of any industry? No? Okay, how does a car get manufactured? Where does it get manufactured? Okay, at some point I'll stop talking at all if you don't respond. Right? So where does a car get manufactured? Manufacturing unit. Yes. What does the manufacturing unit look like? Right. Assembly lines. Have you seen an assembly line in a construction site? Yes? No? Yes? Yes. What kind of assembly line is there in a construction site? What is an assembly line, by the way? Right. Okay. So assembly line as a term itself is not clear. Okay. That makes it difficult. Okay. Okay. Then it's a very difficult question to sort of answer. So do we have a marker or something? Okay. You don't have to even go that far. Let me try and think. Okay. Let me try and think of how many of you have been to an airport? Put in your bag for in the baggage security check and so on. What happens there? Is there a line?
For us, it's a line.
Yeah, for us there is a line, and then there is a what is it called? Conveyor belt, right? On the conveyor belt you have a place where it gets checked. Before that there is a security guy. After that there is another security guy. So there is a line of people along that line, right? Each person has their own job. The guy who sort of gives you the basket or tells you what to put has his job. He's stationed at his desk, right? On the same line, he's stationed at one place. After that, your bag goes to the next guy. So that guy is sitting on a computer and checking what is inside. He is also stationed at a particular place. He's not moving and checking everything, right? He's just moving. He's staying at his desk and on his workbench. After that, there's a guy who sort of checks if there is something to be checked for further details, right? So there are 3 people on that line. Each of them have their own station, right? They don't move from one place to the other. So an assembly line typically is where the task moves from place to place, the person doesn't move, right? The person stays, each of them have their own tasks, and the task moves from place to place. In construction, that doesn't happen. In construction, what happens? You go and collect your work and you bring it and you move around. So first I fix this, then I go to some other place, I will do my task. So if I'm a plumber, I'm going from place to place wherever my task goes. right? It's unlike, thank you. It's unlike your assembly line in factories where you create, for example, if it is a line for, let's say, car assembly, this might be the place where, let's say, your chassis comes. The guy assembles the chassis, so the chassis expert is sitting here. All the task of chassis comes here. Once he integrates it, then it goes to the body. So the guy who's adding the body stays here. They are not moving around, right? So they have fixed jobs, fixed positions, and the task keeps moving around. After the body is added, somebody adds the big screen and somebody adds something else and so on, right? That's so you have a line in which things are being assembled, right? Clear? That doesn't happen in construction, right? There's no such ordered thing in construction environments are. So my question right now, before we move further, so you can, now that I know that we do not have that familiarity necessary, but let's try to see how construction could be different from manufacturing in other ways, right? And to help you with that, I want you to think along these points, right? How is design in construction different from design in manufacturing in the traditional sense? If you're designing a car or you're designing a product like these, is there any difference in design considerations? Is there any difference in the product? Is there any difference in standards? Is there any difference in the size and scale of the product? Right? Timelines. So what is the timeline in manufacturing or the production side, and timelines of design or different phases of production? Production process, work environment, all of those. Does it vary between construction and manufacturing, traditional manufacturing? Okay, I would want you to all to have a discussion at least 3, 4, 5 minutes. At least make an attempt to try and think about it, right? Or else it becomes an absolutely one directional talk, where I'll have no clue whether you are interested in it or not, right? So I'll take a 5-minute pause, and then I'll ask you if there are any insights from your side. All right, I'll stop here. right. So any inputs? All right. Okay. Okay. So are we in for some comments from your side? Any comments on design? Is designing in construction or the design process in construction different from manufacturing in practice?
Both these drawings,
Mhm.
drawings are required.
Right. Yeah, drawings are required, models are required, right? But in terms of the practice and the process and the constraints in terms of when the design should be ready, is there any difference? So let's say, okay, so let me sort of elaborate on that. So what is the typical way of doing manufacturing in construction? Manufacturing, what, are you familiar with CAM, so computer aided manufacturing? So yeah, so CAD is an input to your CAM, and typically you use computer-aided tools to manufacture, right? So your production requires good quality design, documentation, so that you can directly feed through the computer into the manufacturing process, right? A traditional construction does not necessarily involve that, right? So you typically produce your drawings, and somebody goes on the site, looks at the drawing, and starts to build. So the transfer of the digital data directly into manufacturing, which happens in manufacturing, does not necessarily happen in construction. It's mediated by somebody else reading the drawing and then doing their part on the site, right? Human intervention is there. Final production typically in construction is done by the humans, right? They make it, right? That's why the quality depends on who is making it. Whereas, so the quality of your design as a design outcome, which is your CAD drawings or your models, is you cannot compromise that typically in manufacturing, right? Because whatever is your drawing is what gets manufactured. That never happened earlier in construction. We are trying to get there, right? The second, of course, is that everyone wants their house or building to be different, which means there's no real standard house as such or a building as such. Right? Every building is unique in its own way, which means every time you build it, it's different. Whereas if you're manufacturing these, all bottles are exactly the same, produced in thousands and millions at times, right? So you are designing an assembly line where you're repeating the same thing again and again. That repetition is not happening in construction typically, right? You might have repetition in smaller blocks, building blocks, but not the product itself. Each product typically ends up being unique, right? I would want you to, are these reasonable lay inputs? So this is what I'm expecting from you at the moment, because all it tells me that you are thinking on that, right? And then of course, size and scale, right? So you think of a scale of these or a car and think of a scale of a building. Would you be able to use the same manufacturing capabilities as you do an assembly line in-house inside a factory? At best, what is the size? You make a car and so on, right? Anything which becomes bigger than what you are housing, for example, even a ship, how does the ship get constructed? So it's good to think about how does the ship get constructed. In parts, how does it get assembled?
First, its parts are like designed in different, if one part is good in like steel or something, it will design that part. If its part is in different thing, then it get assembled in one place.
Right.
Then everyone like assembler assemble the product like ship.
Right. Have you watched any videos of ship making or assembly? You should watch. So there's some similarity or a fair bit of similarity between construction and shipbuilding. Until recently, until 15, 20 years, 30 years ago, a good part of shipbuilding was still also a lot of workmanship, where people will use hammers and things to build ships. Of course, there was still more production because it was more closer than construction to manufacturing, but still a lot of it was because each ship typically ends up being unique, right? Very few ships are repeated necessarily in terms of repetitions. So all of that changes the way you do manufacturing, right? Changes the requirements that you need for bringing manufacturing to construction. Similarly, I said timelines. Now, if you are producing these, a lot of time initially might go in getting your drawings ready so that everything is accurate. But after that, I can produce per day how many? Maybe thousands, many thousands, right? So whereas in construction, the timelines in terms of production, you're making only one thing, but that might go for 2 years or 3 years, right? A shipbuilding also might go for 2 or 3 years. So you're seeing that fundamentally, if you want to look at manufacturing and if you want to look at construction, they have many differences. In a manufacturing context, your raw material comes to one place, you manufacture, and then the produce gets distributed. So your supply chain is inward raw material, and then your production is outwards, or distribution is outwards. In construction, it's very different. Everything gets centralized. So supply chain is converging towards the site. The site itself is in a location different from where other places are, right? So a lot of planning has to be around wherever you are building it, right? So fundamentally, again, it's different from your other operations in terms of manufacturing, and so on. So I'll leave the other factors, but this is the reason I'm saying is because if you do not think about these, we can talk about all of the, directly talking about the site manufacturing, but why is a fundamental question. Understanding what is fundamentally different is again important, because you can't just apply one set of manufacturing capabilities in another set of manufacturing requirements, right? So even within manufacturing, what your chip making factory looks like, assembly line looks like, will be very different from what your car assembly looks like, just because of the scale and nature of the product that you're making, right? One requires high precision. Well, you'd expect a high precision cars as well, but not so much as a chip, right? It's a very different requirement. Scales differ. So there are different ways to sort of view construction and smart manufacturing, and there are things to think about. First of all, if you think about construction, when you think of construction, what do you think? Maybe this scale, right? A building, or let's say a flyover, or some other infrastructure. But again, you are building largely from a product, a brick, to an entire city. All of this is a construction related project, right? So building scale can vary from making something very small to something very large. Your accessory scale can also vary. You might be using a hand tool like a hammer to actually using a bulldozer or larger cranes. So again, the tools and equipment that you use in construction also vary in scale. Your solution type varies, as we discussed, product to product service systems. The life cycle phase itself needs to be considered. So what do you do in the design phase? How can you use all of these technologies in the design phase to how do you use in the cradle phase, which is that once the building is to be sort of retired, what do you do with it? Do you break it down? Do you recycle the building elements? What do you do, right? So all of that allows you to sort of think about the possibilities of using the technologies in that space. And then of course, stakeholders, people who are directly doing construction to people who are somewhere vaguely connected to construction, they also may have their own tools and methods to use. Again, I'll skip this part. I'll come down to more videos, then maybe I'll be able to better engage you and get more response. So these are some of the areas that we in particular in my group look at. I've just listed 4 of the 4 topics. These are largely where we focus on. The first is what we call as situation awareness. Largely the idea of situation awareness is how do we get to use digital tools and methods to help people know at any point in time what is going around them, right? So if they're part of a project, how do you get the right information to the right person at the right time in the right format so that they do their part, right? Any project is a combination of a number of players, which means everyone should know what is going on in the project, right? And our research at this moment, one of the topics we look at is how do we create situation awareness? How do you know what you are supposed to do in the project at any point in time, right? And how does your action or inaction affect the others in the team, right? That's what a project is about, right? Second area we are looking at is modular construction. I'll play some videos from here on. So, and then the third area is called generative design. The idea of generative design is, how many of you used AutoCAD? Okay, few hands. So typically in AutoCAD, what is happening is that you have a drafting tool like your paper and pen, right? It's just that it's on a digital platform. And you are the designer. You are making decisions on what line to draw, what to do with it, right? So the design thinking and the design reasoning and design execution is left to the designer, which is the human. The tool that you are using, the CAD tool, is largely just a drafting tool, a tool that assists you in representing whatever you want to represent. Whereas in generative design, what we are saying is that the computer can generate designs for you. So you, instead of doing the design, you give it the rules of design generation, right? So you are writing algorithms which are automating the design generation. So you are no more drafting things. You are writing a piece of code or a script, and the computer generates the solutions for you, right? So that is what generative design is, or algorithmic design is. Generative design is one kind of algorithmic design. And of course, we do design for manufacturing and assembly kind of research. So DFX is basically whatever you are designing for sustainability, designing for manufacturing, designing for assembly, so on. So I'll touch upon the first two largely. So there are three segments of presentation now. One segment will talk about situation awareness. We'll start with some of what we are doing, but then I'll play a lot of videos of what is happening generally in the research in this field. Second, I'll talk about modular construction. Again, I'll play some of our videos and I'll present some of our ideas, but we'll also see what is happening generally in the world on this topic. And then third segment I'll talk about is the miscellaneous sort of segment, which touches upon some trends that could be of interest from our perspective. So the first, as I said, is situation awareness. Here we look at a project as a system of systems, as we discussed. And what we are saying is that in any project, you have your CAD tools, information systems, ERP systems. That's one kind of system. You have your smart intelligent products, your intelligent tools, equipment, which have sensors and other things. So these are hardware-based sensing capabilities. You have your social system, basically people, teams, project organizations, and then you have your analog systems, which are non-digital, but a lot of project information is held there, right? In order for you to efficiently do the project, there has to be adequate information flowing between these systems, right? So that is what our research sort of largely looks at, and we try to figure out where is the information. There's a gap in information flow. A gap in information flow means there's some problem that's likely to occur later because people are not talking to each other or systems are not talking to each other, right? So that's one area of research where we do, and we have been doing that work for some time, where the data is collected through sensors, data is collected by people putting information through mobile apps and so on, and then you collect that data, aggregate and make sense of what is going on in the project. I won't go into details of that. Part of that is to sort of improve construction project management. We are essentially analyzing information flow and looking at how the coordination is. We are looking at commitment tracking, that if somebody committed to do something, are they doing what they are supposed to do, right? All of that data aggregation allows us to do analytics. So largely we are focused on monitoring, analysis, and reporting what is going on, so that the project managers or whoever is coordinating the project knows what to do. And we have been developing some tools. It's part of Prajwal's PhD work as well, where we are developing tools to sort of gather information, make sense of it, and then improve project performance. Here's an example of a reporting tool. I don't know whether the audio plays. Okay, the audios are not playing. So any technical support on how to get the audios to play? If the audios don't play, almost half of my videos become meaningless for you. So give me a couple of minutes to solve that. It's connected. It's just okay. Because it's HDMI, it should. I might have to do something here. This video had an audio?
Yeah.
All right. Any system admin people around? Okay. Okay, I'll skip the audio part. Later on, I'll play some other videos. I might have to explain without the audio playing. Okay, all right. So that's one kind of research we are doing. In this, largely, as I said, we are tracking coordination. So we are analyzing this output of some analytics from the research. And then the way you have mission control rooms in defense or in smart cities, similarly, a lot of this research in construction is heading towards mission control rooms. So away from the construction site, somebody could be sitting in an office and they are able to monitor all that is going on in the construction project. So we are collecting data from sensors, cameras, people, and all of that data sort of gets aggregated here, and at one place the core team can manage what's going on, right? It's like a control room in any other, like a space mission control room kind of thing, right? The same thing is beginning to happen in a lot of construction projects. On the same lines, in terms of situation awareness, we are doing a fair bit of research in building operations and maintenance. So how do you maintain the quality of the space that you are living in? How do you do predictive maintenance by sensing whether heating ventilation system is going to go out of service or going out of function? So this work in that space, which sort of collects data from sensors, collects data from users, and aggregates that and makes sense of it. I'll probably skip the videos here. These are just to show how the data gets collected. And these are some of the tools that were developed by my research group in my previous place. Now we are building some other tools and capabilities. So you are able to monitor which room, what is the air quality, air temperature, and things like that, right? You are getting your, and these are runtime data collected, and you can see it from one place. Okay, I'll skip that slides. There's quite a bit of research going on, some of it in our lab, but also in collaboration with our aerospace department, where we are looking at the use of drones for inspection, construction site, project monitoring. So you can use it at different phases. Before the construction starts, you can do to map the terrain. So you are actually using drones to survey the terrain and then create a map of it. During construction, you can do it for project progress monitoring. So you are actually checking how much of construction is done compared to what was planned, and then you can bring all of that data and do analysis to see the progress and so on. You can do safety inspections, whether people are following safety instructions, are there safety gaps on site, and things like that, right? You can look for deviations to what was planned versus what is the situation. You can analyze those deviations as well. Post construction, you can of course again map the scene and create a digital twin. You are able to capture the reality, do laser scanning and otherwise photogrammetry, and then you are able to stitch that back to create your visual or the model of what is out there, right? So some of this research is going, of course, you can still do inspection for defects. So if a facility has been around for 10 years, you can run your drones to see whether there are signs of defects and things like that, right? So you can do those kind of analysis. The area of digital twin, again, how much familiarity do you have with digital twin as a concept? Anyone? Digital twin? Okay, how many have heard of digital twins?
Basically, a digital rendering of the physical system.
Right. Yeah. Okay, how many of course, all of us know what is a twin, right? So a digital twin as an idea is essentially saying that for each product that you have a virtual model of it, which is its twin. And it's not just a virtual model as a CAD model, but it's a twin that is connected to this. So every time something changes here, something that is of interest to this, gets updated in your virtual model, right? So whoever has access to the virtual model will at any point in time have information on what is going on with this thing, right? That's one directional connection. Still the twin is not complete. So typically you will also have the ability to do something on the virtual model which affects this as well. For example, so I talked about, let's say the car. So let's say you buy a good car from a company that is monitoring your engine. So it has a model of your car, that instance of your car. So each car has a model, virtual model. It doesn't have to be looking 3D per se. There's some way to represent your car in their database, right? And your performance of your car is getting monitored on a regular basis, so that they can track what is going on with your car. And if they want to say update something or fix something, you could potentially remotely sort of activate some things to happen in your car as well. For example, you might have an upgrade in your software or something else. it doesn't require necessarily a digital twin, but that could be one way to do it, which is to say that, okay, this at the moment, this is in this state, we need to tweak something in your system. So that bidirectional connection allows it to be a digital twin, right? A twin then allows you to improve your system and also better monitor and track what's going on. So we are doing a fair bit of research again there, where we are saying, okay, if you have a twin, how smart should the twin be? What is the role of the automation? So how much agency or in capacity should the twin have? Do you want it to be very intelligent so that it can, for example, let's take this example here. So let's say you are in a room where you want to monitor room temperature, right? So without the need for a twin, so typically the way it would work is that you as a user monitor what is the room temperature. You report, you take the decision of what happens, and you decide whether you want to change the room temperature or not, right? This is without any connection. The second stage could be that you have a sensor which sort of tells you that this is the temperature, and based on that you take a decision of what to do next. The next level could be that you have a sensor which communicates to your twin, which decides automatically what should be, so it automatically adjusts the room temperature depending on what should be done, right? So the human is taken away from the loop. So in this case, what we are saying is as your twin gets smarter, the role of the humans get lesser, right? Automation takes over more and more of the roles, and it becomes more intelligent, right? So that is what some of the research is sort of looking at, is what it requires to create this kind of digital twin, and what is its usefulness, and so on. This is sort of a framework again which says that, okay, your decision to implement a twin in any company is not purely just a technical decision. There's a bit of a market pull of what the market requires, and there's a bit of a technology push. And it's a negotiation between what you have as a potential technology, what you can do, versus what is the requirement in the market. You might have technologies, but your requirement may not be there. You may not be able to invest the amount of money or get the returns from investing in a technology, right? So it's not just a technical decision, it's a decision which is also to fit into the process of the organization or the market for that matter. I'll skip this slide again just to show that if you use these kind of tools and methods, your efficiency can significantly go higher, even with marginal changes in the process. It's on the same lines of how smart your twin can be. So there are some strategy models. I'll skip that again in the interest of time. And I think from a familiarity perspective, so let me play some videos now. Let's hope that if not there, I can play the. So this is a video which is about 20 years old. So it's not a new video, and it's a video about introduction to BIM as such as a capability. When it was made, BIM as a tool was not a popular term. Is anyone an architect in this room? Okay. So Frank Gehry is one of the celebrated architects, and he makes some very complex buildings. And basically, the point he makes here in this video, which you will watch, is that if you use the right tools, even the most complex buildings can be built within the same budget or more or less as what your simpler buildings are made. Right? You can maintain the quality, you can look for all kinds of things. So I'll just play that, and then hopefully the video makes sense.
The first project of significance was built up, and we took our team to build out. They spent a week with the 6 steel subcontractors, and they trained them how to use Katia. And the bids came in 18% under budget, 6 separate contractors, and 1% spread. And when I saw that, I realized we got powers here that architects don't usually have. The latest thing is the curtain wall for the 76-story tower, a rental building in Manhattan. The facade looks like wrinkled cloth. stainless steel. There are no two pieces the same. It's based on trying to get bay windows. So when you're in a tall building in Manhattan, you go against the window and it's flat. And if you can walk into a bay window, all of a sudden you're in outer space. It's a whole different experience. And with CATIA, they were able to corral that into a reasonable cost. And when the day it was bid, the final bids were $200 a square foot. That same week, flat curtain wall in Manhattan was $200 a square foot. So that's the miracle of stuff. You can control costs, and you can do stuff which can only be done with CATIA. You can't do it with any other software that's out there. And it allows for the elimination of collision. So if somebody makes a move that's starting to interfere with mechanical or the lighting or the structure, it's immediately noted, the others catch it, and the issue is addressed right then and there. The savings are clearly there, and it can lead to architects being more in control, taking more responsibility, and delivering better buildings. If you can have the building department electronically approve a building online, you realize how much time that saves. A 76-story building would be a pile of plans this high. It's better part of a year before they can really figure it out. Whereas if it was online 3D, they'd get it. The CATIA program could just take off with that. And the clarity and the amount of detail that we could put in it would be enormous and very powerful. Once you get into it, you can do project management. You can do a lot of the organization's delivery materials.
All right. In the interest of time, I'll stop that there. But did it make sense? I mean, was the accent clear? Understandable, right? Okay. So, anyone wants to conclude what they found in this video? What do you say? Any volunteer? You all heard the video. So, somebody could summarize it for us. No volunteers? I don't want to make it a class throwing a chalk at somebody to answer. It's not very good. It's a very passive audience. It's a stalemate, so if you don't speak, I don't speak.
Construction construction
Right.
shapes
Yeah, but what is this? What is the conclusion? Summary. Construction, yes, but what is the summary of the gist of the video?
the different shapes with which wind motion
Right. Okay.
So it talks about how leveraging CAD tools, right, essentially improved the overall life cycle of construction project, wherein you was able to get down the cost some 18% than the initial planned budget. So
Right.
that's a key takeaway as to how using CAD tools, right, potentially can essentially
Right.
lead to improved project management
Right.
from a
Okay.
construction perspective.
All right. Okay. I'll go ahead with that. So, I mean, there are enabling technologies. As I said, if you're using or you're looking at Industry 4.0, then your information models or the digital basis itself, the digital model itself becomes the central element. Right? So, this is where BIM tools in construction context become important. Of course, the equivalent of that in manufacturing is product lifecycle management tools, PLM tools. So the idea of a BIM sort of an approach is that everyone more or less uses the same digital infrastructure to do the design, maintenance, operations, and so on, right? So it's the same set of tools, or at least the same set of data that goes on from one tool to the other, right? So you have an integrated approach to doing it across the life cycle. Given the passiveness of the class, I will skip the theoretical part and I'll play more videos. Essentially the idea here is that when you move into BIM tools, you're not looking at traditional CAD tools which are just your drawings. Now you have your data embedded into the, so in a object-based model, in BIM you're actually picking up from things from object library So all the information about the object. For example, if you pick a door from your library and say this is the door I'm using in my construction or in my building, then it has all the properties about the door. So anybody can click and see what all are the specifications of the door. Whereas in a typical CAD tool, if you're drawing the door, then you have to separately have a specification sheet saying these are the specifications of the door, right? So that's a huge difference, and that allows you to do all kinds of analytics. The second part, which many of these BIM tools allow you to do, is also to manage. These are information about managing processes, managing people, and so on. And once you get this kind of information models, you can do all kinds of analysis with it. You're checking whether the building meets the regular code requirements. You can do structural analysis, energy analysis, and all of these, as I said, are central to the idea of improving sustainability of the building, of the design. In some sense, if you, from a BIM perspective, the conclusion there is that you can do all kinds of analysis on top of that. And here is another sort of video. So now will be, as I said, lots of videos, and I guess that's easier to sort of make sense of. Right. Okay, so now I may not be connected to the internet, so I need access to internet. Do you have access to the internet here?
The ability to plan, manage, and track projects in an integrated space-time visual environment provides benefits to all types of construction projects. Synchro's digital and interoperable platform enables improvements across all aspects of the delivery process, from safety, workspace utilization, productivity, quality and reliability, project cost and competitiveness.
Construction projects tend to be projects with a lot of parts, labor, materials, scheduling constraints. If you don't plan all of those issues out at the time, then you're good for failure.
Synchro gives the guys who do the work a solid understanding of what the schedule is. Bring in experts in the field, they tell us their challenges, their changes, show options, and they can confirm, yes, this is what we plan to do.
We're able to catch things sooner than we would have caught, and we're also able to explain to the client who sometimes has trouble visualizing the 2D, but can clearly see what's happening in 3D, why certain issues are safety concerns, why there are certain logistics, and why certain things can be done, can't be done. Execution of 4D and Synchro will help project keep pace with the changes, and thus will avert extensive rework, will improve the schedule as the job is progressing, and serve the needs of higher quality and higher level safety. We use Synchro as a planning tool to identify safety issues and then actually flag those issues inside the model.
Visualization, simulation provide so much better communication about safety and risk. Team effort and drop projects to none. Freedom managers to none.
So essentially, in these kind of tools, you sort of build your virtual models up front. So you do your entire project planning, you say during what time of the project what will be built, and then you are monitoring the progress, and then you're feeding it back into the tool, and then you can re-plan your schedule. So basically, on a regular basis, you are looking at what is happening, updating your models, and so on, right? Okay, so the idea there is that as you move into these kind of tools, you are doing more corrections in your design stage, and the more corrections you do in your design stage allows you to sort of fix your potential errors. So in a typical non-BIM sort of an environment, you make a lot of mistakes in your drawings, which get reflected only when you are actually starting to do construction. And when you make those modifications during construction, it becomes a very costly affair, right? If you can bring that up front and make all the corrections in your virtual model, in the virtual design and construction phase itself, then you are reducing all the rework costs and other things. The other way to look around is when so far if you think of design, you think of starting with your blank sheet and you're designing for something to be produced. So you're going from a virtual model to creating a physical thing, right? But in many cases, you might have things available which you need to scan back. So you are creating a model from things that are already there in the place, right? So there's another, so this is where laser scanning, photogrammetry, and other tools become useful. Okay, I'm now skeptical of playing more videos, so I'll see if this plays.
As the construction industry embraces technology innovation to address workforce challenges, augmented reality solutions from SRI International have the potential to transform job site operations for construction inspectors by saving time, cutting costs, and improving safety with intuitive equipment and connected intelligence. Conventionally, the inspection process is done manually, often requiring more than one person, and can take a long time to document and circulate the information to others. SRI's computer-aided system can accurately track user location as they move around a large job site. With instant access to an intuitively searchable digitized database, an inspector is able to accurately align and compare what is being built against the building information model. Manual measurement processes become automated and more accurate. Capturing and documenting data become less time-consuming. The inspector can snap photos on demand or add and retrieve virtual notes that stick to a location, which can be shared across multiple devices. Problem areas become easier to recognize, and serious concerns can be identified and shared instantly with those who can immediately respond.
So once again, in interest of time, I'll move on. But a number of these tools are not just now in R&D labs, right? They're actually being used in some places, and hopefully in the 10-15 years, we'll see more of these tools becoming reality in many of the construction sites. It is again a continuation of a similar video, so I'll skip. There are some other interesting elements, but I think we have about 20 minutes, so I'll sort of try and wrap next to. Now here is another part which is interesting. So this, if you sort of, okay, this requires internet, so I'll skip these two. This also will not work. So basic idea is that if you are now thinking of your typical shopping experience, where now you may not even need to carry your card, because as you walk along, you buy your grocery, you walk out, and you are being tracked to RFID reader or otherwise. Similar things are beginning to happen in construction site as well. As the material comes and enters through the gate, your system automatically detects what is the material you are bringing to the site, where are the parts going, what is going out. So with the ability of RFID readers and other techniques of similar kind, you are able to track and monitor movement of equipment, movement of resources, movement of people, and then update things on the construction site, right? Makes things much smoother. Just like what you use as fast tags, for example, in your expressway, right? If you move around, you are getting tracked that this is the car that went through, right? Those things are already happening in some of the construction sites. Let's skip that as well. So the second part, which is the more interesting part. So here, what we are interested in is to bring modular construction. So this is a company called Commission, which is based in India. They already do this kind of construction, and we are partnering with them to take modular construction forward. So instead of building walls and elements separately, you are actually precasting the entire room at a time. So within 8 hours, you can make an entire room. This also had a video, but not required at this stage. So this is within 8 to 10 hours, you are able to build the entire room. So if you are building, let's say, a 10-story building, you should probably be able to do in 10 days or 15 days or so. And of course, then you go on to do your internal details and so on. It's already happening in India. There are companies which are doing. Mission is an India-based company. The cost, if you are building in sort of bulk is in a scale, it more or less matches the regular cost. Because it saves a lot of other features like wastage on site, so it becomes much more sustainable because there's no wastage really, right? If you go on a typical construction site, there's a lot of wastage happening, there's a lot of movement of things. So typically what you do is they take this mold closer to the site and build the rooms on the site and then you assemble. If you have a larger, and the future vision is that you could also have an assembly line you could build on a larger project. So that's happening already. The cost is comparable, especially again if you look at the durability and quality and all of that.
These are more from a residential sort of a project, right?
No, not necessarily. So they have built institutional projects as well. So in fact, there is one Goa airport also they have built for the police station.
So more of metros are done like this.
Right. Right. Yes. Yeah, precast is it's regularly used for your bridge construction and so on. Yeah. So we are taking the same idea forward in a slightly different vision. So I'll show what our vision is, right? So what we are saying, as we said, about productization. So this is sort of inspired by what you have as vertical parking buildings. We are saying something similar could happen in future of spaces. So you could buy your own apartments and bring it to your location. So you could, let's say you are buying an apartment independently. Even in a vertical building, you might have your own slot, and you bring your apartment and insert it in the slot. So you don't have to necessarily be caught with the apartment that is given by the general contractor, right? And right now in our lab, we are sort of building a scale prototype of this, and then all the implications of all of these going forward. Yeah, so you see your thing. You can take in and take out an apartment block and move around. So it doesn't have to be the entire apartment. You can have rooms as well. So tomorrow, if you want to change one room, just like you change your fridge, you should be able to take that room out, replace with another room, and your house is a collection of these 10 blocks. That's a very schematic thing, of course. This was done in a very early stage to discuss the idea, but we have moved further ahead in our detailing of these things. Yeah, so that's another area where we are looking at buildings as products and changing the way we think of buildings as such. And this is no different. So we are looking at some other examples. You already have this kind of parking buildings. So instead of the car, you can think of an apartment being brought in and brought out, or a room being brought in and brought out, and your house is a collection of those kind of rooms. So again, I'm assuming that most of you would have seen this kind of parking buildings, right? So I'll skip the video again here. Then of course the idea extends not just to working basically vertical buildings, but we are also looking at similarly taking the idea of modular healthcare facilities, and we are doing some research in that space as well. Yeah, so again, there's a lot of research already there in terms of prefabrication. So you have non-volumetric elements, you have volumetric elements like bathroom pots and so on, and then you have pre-finished apartments. So here it's already happening in many places in Singapore and other places where the entire apartment is finished. It's already furnished as well with everything. You bring in and then you are stacking one above the other. There are of course technological issues, not just for the apartment part but also the services part. MOP systems can also be managed. And there are different ways of doing this construction, stackable parts, non-stackable parts and all that. So, okay, so and then I think this video will not play. So this is again on using construction technology of manufacturing for prefabricating building components at larger scales. Alright, all of these now will not play because of the internet issues. So in any case, I think in the interest of time, we'll pass it on. So have a look at the 3D printed, there's a video of this 3D printed post office that's done in Bangalore. This entire building was done in a day, a 10-story building. This probably is not in Bangalore, China, and similar thing was done in, yes, yes. And in Chandigarh, someone built within 48 hours a 10-story building. So people are already beginning to do this, and it's changing the way construction is being done. Right. Okay, so my computer seems to have hung. Give me a minute if it works. Okay, the same thing again happening in structural health monitoring and so on for bridges. A lot of things happening in smart buildings. Again, the videos may be more risky to place in terms of internet issues. How many of you have heard of the project called The Line? Has anyone heard of The Line as a project? Okay, go and Google The Line. It's a building, or it's not a building, it's an entire city coming up in Saudi Arabia. And look at the video of what they are planning. It's again a very interesting way to think about how the future of urban spaces could be. They're trying something very different. It's an entire city which is on a single line, 13 kilometers, and largely everything is enclosed within a couple of walls. The width of the city is something of the nature of about, I don't remember, but something between say a kilometer to 2 kilometers. So the width is 2 kilometers or 1.5 kilometers, and the length of the city is 13 kilometers. And everything, the entire city is being built within that single line. And because it's such a confined sort of city, you can rethink how public transport works, whether you need cars or you don't need cars in the entire city, right? A very interesting project, so look at that. Okay, lots of things happening at city level, where you are having sort of automated parking systems, which tells you where the parking slot is available. If you are going there, what is your rating for price at that point in time? All of those things is already happening in smart cities context. A lot of things happening indoors now. So that's what I said. This it's scale independent. Your ability to leverage IoT, leverage sensing capabilities, leverage your machine learning and AI has now gone beyond scale, right? You can look at the product level, you can look at the house level. Again, this video may not play, okay, it's not. Look at what is called ORI furniture, that's just as an example, ORI. These are furniture where the bed goes up, right? If it has a sense of a button, press of a button, or it can sense whether the user is there or not. The entire bed goes up and the study table comes out and so on, right? So this kind of smart furnishing again leverages the same basic idea, right? You're using smart technologies to change things.
So how about the artificial island that was built in?
Which one?
There was an artificial palm island that was built in.
Yes.
So it is also more on this.
Yeah, so that is more on the geotechnical side. I think it largely figures out, how to sort of consolidate the soil, reclaim. So, yeah, it doesn't necessarily, but yes, I'm assuming that you can still use a lot of technology to sense whether it's stable or not. So it's health monitoring and those things are
If
different.
it was on
For the island part, I don't know. I have no idea there. I haven't checked this. Okay, so this is another video of where things are happening in construction with regards to, not in construction, sorry, in terms of assembly process. So here is an example of using augmented reality to use to improve your assembly line. So basically, if somebody is working on the workstation, it guides you through the entire assembly process. If you look at the tool is also smart, it's sensing how much torque and so on, right? So you are able to, it's not just now left to the person to feel whether I have tightened it or not. You're getting a feedback. It's guiding you through the sequence of activities that you need to do, right? So it's the entire guiding process. Okay, in the interest of time, I again move on. Similar kind of tools using slightly different technology, but the same idea. The idea to how to help the person assembling or doing the task, guide them through the entire process. And it's already been used in many companies in India for training purposes, right? And
It's not hands-off.
that's not hands-off, no. Okay, so that is hands-off, sorry. So you have a wall mount or screen, top-mounted projector, which is projecting everything. So what you see on the screen is largely coming from the top-mounted. And the rest is, of course, when you're using the tool, the display is on the tool itself. So in that sense, yes, it's hands-off. I'll play one other video, again probably the last or second last, last video because the others may not work. So this is a video that
thousands of options for drawing, all of which meet specific goals.
This is a video on generative design. Again, I realize that, so one way to look at this session is to look at that there are things to look out for, given that you do not probably know about it. But look out for generative design as well as some of the things
set by designer. And from those options, pick the one design that delivers on the most important criteria, the design you couldn't possibly imagine. This is generative design, a technology that harnesses massive computing power, creating forms with precise amounts of material only when needed, achieving maximum performance while wasting time. Generative design can be about much more than simply turning out alternatives. Prototypes can be scanned and equipped with sensors that provide real-time performance data that can loop back into the design process so the object, in effect, co-designs itself. And depending on the material and method of manufacturership, the software can optimize the design of those choices. In its search for the optimal design, generative design creates complex forms that would otherwise be impossible to make using traditional manufacturing methods. Now with advancements in material science and the ability of 3D printers to print in bulk, companies like Airbus can create forms like this airplane partition panel that's half as light and just as strong. The result? Significant reduction in fuel costs and CO2 emissions. The things that polluted us in the past, software, materials, manufacturing, no longer do so. With generative design, the world can look and perform any way we want it to. This is the next stage in the evolution of design, and it's happening now.
So the basic idea there is that if you typically build with standard,
You can come up with thousands of options for a single.
if you typically build with standard sections, right? If you right now build columns and beams, use standard regular sections, but the load distribution is not uniform everywhere, right? So the idea is that through topology optimization, you are taking away all the unnecessary material where it's not required, right? So you can make very light things with fewer material and perform the same or better, right? So you are getting lighter structures, may not look the standard columns or sections, but then it takes away all the unnecessary material away from there. Right? That's one of the advantages. There are many other advantages, of course. I'll skip this video. You might have seen the video of Amazon warehouses where the things are moving around. All of that is indicative of where things are going. So at this stage, if you are not aware of these, in the next 10 years, a lot of your jobs will be affected by all of these, right? So it's high time at least that whoever is a student in this class should start looking for these things, unless you are looking at very stable and routine jobs sort of activity. Then there are of course other kinds of tools around which now do site layouts. So these are robots which go and lay out the site before construction and so on. So we're taking away a lot of these manual jobs by bringing more precision in your process. Okay, this is a concluding video. In some sense, a summary of something. Again, sort of a relaxed video, something that you all have potentially felt but may not have thought necessarily about it. So 1981s to where we are with the evolution of the desk. basically the idea is what it's saying is that reality around you is changing, right? A lot of things that were physical things do not exist anymore. Now when we talk about calendar, we normally talk about calendar and our screens, right? And lots of other things. So a lot of things that you assume today will be true for you in the next 10 years is going to change dramatically because of the augmented reality, virtual reality, and other capabilities that we have. So if you don't start thinking, you'll be in for surprises, and that might affect you. Right? So it's good to start thinking of opportunity because a lot of opportunities exist in imagining and creating solutions which create new possibilities. Right? So tomorrow's shop floor may not look the same as what it looks like. Right? A job may not look like the same as what it looks like that you have to go to an office and sit there and do things. It's already beginning to happen, and when it happens, it will happen very fast. Because if there's a business case, companies will just adopt it, right? So if you're not alert on this, you'll be in for a surprise, right? So my only suggestion from all of this is that things are changing and things changing fast. So at least even if you're not into it, be aware of it because you don't want to be caught unaware, right? Okay, with that, that's just the recap. So things, of course, written from the point of view of the presentation I made is about construction, but largely it remains same for every other industry. We are moving in an area where I think we are going to be part of system of systems, things which are connected. We are going to be affected by how we perceive physical and virtual things around us. You will have heard about things of excitement around metaverse and all sorts of things. So things are going to change, many of the things. So either sit on it and drive the change or creep about what is changing around you. So with that I'll stop here. Thank you. Any questions? All right. I've exhausted faces and relieved faces that is done. So okay, with that I'll stop here. Thank you. Yeah.
Sustainability lies on social, economic, and environmental. All these things, it will develop construction for that need like factories and all. It will be huge construction in future. How it will affect environmental? We are looking really to environment. Like
Yeah, in fact, we are. Because it's distributed, it's happening on sites, the quality of managing sites is very poor. Right? That's one of the reasons Delhi stops construction every few months because there's a lot of pollution happening on sites. So when you get very organized and more precise about, and you reduce wastage because now you're not having say a good portion of your concrete or other things that your cement getting wasted on site, right? So when you do all of that, you'll see that we have significant improvement in our sustainability of or environmental impact that these things bring. This is more controlled environments where you produce only what is required. Yes, there will be aspects to consider, which is transportation and so on. So yes, there will be, but if you do the real trade-off, will be much better off. Right. Okay. Any other questions? Okay. With that, then I thank you all.